Good morning and welcome back to this wonderful workshop again. It is my great pleasure to welcome four of our very illustrious colleagues to talk about their experiences, both in terms of their career journey as well as their interaction with the Informs QSR section, and then share some of their ideas about what they think can be the future for our section, as well as some advice for many of us who have been in this section for some years now. The first member of this panel will be Dr. Susan Alvin. What I will try to do is have each one of them provide a brief overview of their thoughts, and once all four of our speakers, our panelists, give their initial thought, we will invite them over here and we will have a general discussion. Okay. And in the next 45 minutes, about 45 minutes or so, we will hear each one of the panelists out, starting with Dr. Susan Alvin. And of course, all four of them probably don't need any introduction for our section. All of them have been leaders in our community. In fact, Dr. Albin has been a 16th president of Informs as an organization itself. And all of them have been involved with our section at various levels and have helped grow this QSR section over the years. So without further ado, I would like to invite Dr. Susan Alvin, and please join me in welcoming her.
Can you all hear me? Yeah, I'm used to this work. Okay, happy birthday QSR. So, I didn't realize this morning before I came or when I wrote this talk, but apparently QSR people do not like to follow the rules. Oh, I need more time. I know you told me one time, we'll do another. There's no break, everybody sit down. So this is how I began as a panelist member. Dear Satish, for my 15 minutes in the panel, I have my heart set on something completely different from your plan. I want to tell everyone about active learning and what it can mean for students. I hope you will make an exception for me and allow me to use this opportunity to convince even one of our QSR colleagues to try it out. With warmest regards, Susan. So those of you who know Satish know that he always finds a way to make everybody happy with the solution. Dear Susan, it is so nice of you to introduce active learning to the QSR community. Is it possible to spend some time of your presentation to reflect on your involvement with Informs and QSR, as well as your thoughts on how QSR community can extend its impact? Thank you very much, and I look forward to meeting you on Friday. So, that's how it started. So, I'm going to begin with my academic journey, and it begins with Sputnik. This was a satellite that the Russians put into space in 1957. I was not in graduate school in 1957. I was in second grade. But this really energized the United States to train students in what is now called STEM. And this inspired the New York City public school system and many school systems around the country to really create special opportunities to train students who are interested in science and math. The next milestone after my high school education was I discovered industrial engineering. So this brings us to the late 60s. Here is my snide rule, and it was a deep skin, which means I really had made it in engineering, not plastic. It was a good one. And so I heard about industrial engineering in the way that many people do. You're required as a first-year student to take a course that introduces all the engineering majors. The minute I heard about IE, I could not believe I could major in something that was already in my head. My head was filled with this idea of optimization. Which line in the supermarket, how to organize silverware in a drawer. That's what was in my head. And the second part of it was really something in my heart. I just have always truly recognized the uncertainty in the world, in systems, in people, in machines, and then later, as I discovered, in software. I really appreciated this uncertainty. So then I heard I could major in this. The next highlight is my PhD with my most remarkable advisor, Ward Witt, who's now at Columbia University. So I joined Columbia after I had worked for 7 or 8 years in medical school, and I'd worked at Pfizer and many other places. I joined Columbia for the PhD, and this is simultaneous with my time at Bell Labs. And this is a queuing network, which was the topic of my dissertation, and this is Ward. So, it was a very interesting thing to read my own CV. And what I have here is this sort of evolution, and I think this is really an evolution that would describe our field. So, my earliest works have to do with univariate statistics. Don't assume it's normal, basically. And a lot of this had to do with semiconductor manufacturing. Then the next stage was multivariate, considering more than one variable at a time. And a lot of that had to do with food processing and more continuous kind of manufacturing systems. Then profiles came along, which added the time dimension. And then my OR side and my quality side merged together, and there was the idea, okay, once you have this model, now let's optimize. And then, instead of data coming from, on a clipboard with a few pieces of numbers, data started coming in gigantic amounts. And so then the focus was on handling large amounts of data. And I completely agree with Professor Wu. Whatever you're doing, call it machine learning. Quality sometimes has, a connotation that is old-fashioned and so on. But if what you're doing is learning from data, and it's plentiful data in particular, people believe that this is what they're working on. And so this is something I think we should take a broader view of what we do. All of this work, without exception, has come out of real problems, starting with semiconductor fabrication, food processing, suture and recycled plastic extrusion, and flat glass display technology, mostly with Corning. So this is one of the lessons I learned from my thesis advisor and from my experience is don't look for problems in your head. Go someplace else. Reach out to other people. Reach out to companies. It's time consuming, but definitely do it. Look in the literature. Don't try and just generate it from your head. So, my first time at an Informs conference was in 1990 in Colorado Springs. And I came as part of the Bell Labs contingent, which at that time was 30 people would come from the OR division simultaneously. And the next thing I want to mention that happened is, this is the power of professors. Ralph Disney, who was a professor at Virginia Tech at the time, said to me, why don't you run for the Council of Applied Probability? And me, the idea never came to me. So this idea of, if an opportunity comes your way, just say yes. So I said, okay. And that was really a turning point. Then soon after that, we founded Women in ORMS, fondly known as WORMS, which has been an extraordinary successful part of Informs. Now this red scary bar has to do with, at this point I would have left Informs. My research had no community, no people to talk to, nothing. And if it weren't for Jan, that would be the end of this, and the end of my talk, and the end of it. End of anything. So, 1998, 20 years ago, Jan is the moving spirit for QSR, and here we are. I was active in QSR, but also active in the greater Informs. I served on the board of Informs and as secretary, and I'll tell you what was valuable about this. So, many people in the applied math subjects, whether it's statistics or operations research or IE or whatever it is, we like to find out how other people do their business. And I was really amazed at how complicated it is to run a society like this. And this is what I learned as a board member. It was well worth doing. It was a lot of time and a lot of effort, but if the opportunity comes your way, or if you're even a little curious about it, you can help the opportunity come your way a little. You should do this. And then in 2010, I became president. And what I learned there has really benefited me at my home university, Rutgers, for many years since. I learned that to run something successful, you need a strategic plan. Now, when I first heard this thing about strategic plan, I kept saying, as those of you who know me, I don't get it. What's a strategic plan? What is strategic? But now I know what it is. And basically, the key strategic plan that came out of when I was president, it was not my idea, but I certainly supported it. It was the idea of Jack Levis and Ann Robinson. It was to broaden Inform space and include analytics. In other words, include all the students who have master's degree and we have trained, and who have PhDs but are not working in universities, and to include them and make Informs useful to them as well. So this is my evolution in Informs. So, how QSR can extend its impact in Informs. I only want to talk about one of these, because the more I heard this morning, just 2 minutes? No! No way! This is what I want to talk about, the Edelman Prize. All the work that you have discussed has helped companies in a big way. The Edelman Prize, we very humbly at Informs call the Nobel Prize of Operations Research. It's the use of the kind of work we do to really move a company forward and to have a big impact on the company. So things like Orion at UPS, how to route all those trucks and how to organize all that. That's the kind of thing that competes and wins. To connect what we do to giant impacts in companies or other organizations. It doesn't have to be a profit-making company. Two previous winners that I can think of the Edelman. One is the country of the Netherlands in organizing their dikes and so on. Another was South Africa in organizing its government budget after the fall of apartheid. So we need to be more visible. So all this is true, but I think the Edelman is something we could aim at. And as a sort of warm-up to that, the Wagner Prize is another one. Now, I can't not talk. Is that okay?
Please go ahead.
I'm just going to highlight two of these, okay? So this is advice. In yourself, know what it feels like to know something and to not know it. So know when you've got it and know when you don't have got it. And then if you want to know it, ask somebody to back up or to repeat it or to tell you until you feel you've got it. So this is important to me. And the other thing is curiosity. So in engineering school, the alumni come back and they tell the students, follow your passion, which I think is terrible advice. People don't always have passions. And they don't start off as passions. And it makes it sound like you have to sacrifice your children or something to follow your passion. Just be able to feel curiosity in yourself and pursue it. That's my advice. So, curiosity. I became curious about active learning. When I first heard about it, I said, this has nothing to do with me. My lectures are superb. I have refined my notes over the years. The students love me. I am totally not interested in this. But now I'm completely hooked. So in my classroom, basically what I do is I give short chunks of lecture. And this number 10 is not because I have 10 fingers. This has to do with the biological reality of how long people can concentrate. And then I pose a question that all students must answer, not just the good students sitting in the first row who raise their hand. Okay. This is in a loop, spending the lecture time of my classroom. And then the students are solving problems in assigned groups while I stroll around. So in a class of 70, I'm able to get physically next to and talk to every student every week. Oh, you forgot to find that, walk around, help answer questions, and so on. And there is individual accountability for all the students. So now I'm going to give you a clicker question. This is the kind of polling I do after a chunk. This is an easy one, and we'll do it as follows. You have to pick the answer. Well, I use clickers. I do it with technology, but when I say 3, raise your hand and put up fingers. 1, 2, 3, 4. 1, 2, 3. Raise your hand if you know the answer. Only one person? Oh, everybody has to go back to the first class. All the PhDs in this room, I'm taking them away. So yes, the one person who answered has it right. Yay. Thanks to Jeff Wu. This now, it's always very easy to show this graph, but it is very hard to explain that number, the interaction term. And so this is a typical clicker question when I'm teaching that subject. So I ask the students which is true. I will give you a minute to read this because you all should know this very well. Okay? The correct answer is all of the above. Okay. And here's a question that students always get wrong. We've made a model. We had a full factorial with 2 replicates. We have a model. And this is a setting that optimizes the 2 like. What is the best predictor? They always want to say, go back to the data and take those numbers. Don't use the model. This is a gigantic intellectual leap that as students are learning our subject to believe in their models. So these are the kind of examples that come up every 10 minutes where every student must answer. You can also use this to start a conversation, like on continuous improvement, for example. Here are all the reasons that you will give me of why you shouldn't do this. So many of you are way ahead of me in doing this. Works even better in large classes. It's even more important. I don't have a high-tech classroom, no problem. You can use paddles, you can use fingers, but clickers are very fun and the students like to look at it. How can I possibly cover all the material with so much fooling around? And the answer is, you will cover more. In the same way, you submit a very nice paper, you get a referee report that tells you to add 10 things and reduce the length by 20%, and then you've really written a great paper. Too much additional work, It is. It's a lot of work, but you don't do it all in one shot. You add one clicker question per week the first year. One per week the first year. And it accumulates over time. Like 20 years passed like nothing. So it's not something you do all at once. There's gigantic scientific evidence. The Proceedings of the National Academy of Science is an article that's a meta-study of 225 studies. Average exam scores improved by around 6%, so like B to B plus to A, and so on, in active learning classrooms. And when they say active learning classrooms, they say at least 10 minutes in a hour-long class has to do with active learning. So it's not a big definition, not the whole time. And students in traditional lecture are 1.5 times more likely to fail than those in these classes. And I have done a non-scientific study. This is a probability class that I teach, formerly known as the organic chemistry of IE. I have 7 years of data, and I started using these ideas in the middle of it. My class size has increased from 30 to 70, and I have similar results to the other one. So I hope I've convinced at least one person here to do this. And thank you for putting up with me, Satish.
Next, I would like to invite Fugee-san, who has been one of the very active members of our section over the years. And he probably has a distinction among the panelists here to be on the other side. He actually was a chair of our section for some years, and then moved on to doing other better things now. And without further ado, let's join me in welcoming Dr. Tsung.
喜欢。
Thank you. I'm Fugee Tsung. It's pretty honored to be here, and then it's just suddenly 20 years. Oh my God! So I've been the QSR former chair in 2004. That was a long time ago as well. And currently, I'm still the editor-in-chief of JQT. And then I will actually talk about that. And I'm from the Hong Kong University of Science and Technology. Thankful Satish he proposed some questions. Basically, I will follow that and give some of my thoughts. The first is try to do a brief recap my academic journey and my involvement with the memory of QSR. I put things together and realized these two actually is the same thing, and they almost happened at the same time. So I put in the picture here, some old picture, and the year there actually is respectively, that's the year. And the first picture is in 1998. 1998, I was there and Judy was there too. Hope you recognize it. Jen, if you, actually the fourth one is Jen. I did not realize how important that is, just because 97 is the year I graduated from University of Michigan, and actually Jeff Wu and Jen Xie are both my advisor, and I'm kind of being asked to attend the conference. And at first I thought it's a one-time deal. I did not realize that actually the following 20 years I almost come for everyone. Not everyone, but almost, and I try to. 97 actually is the year that I graduated and I moved to the Hong Kong University of Science and Technology. At that time, actually, I don't have much idea about that university, but for the reason that's a choice, and then I want to move to Asia and close my parents. Actually, that was actually a consideration. And I talked to my wife and think that it's still young, and this is the first job. Maybe after a few years, I can go to a different place. and then but you need to know the importance of first job. So after you go there, and then you just stay there. And over the year, that university actually is growing and then become famous. I'm very happy with that. So 97 is the time I go to Hong Kong, and 98 I attend that conference. Here showing that the 202, actually that's a panel, that's the editor panel. I'm not sure it's the first one or not. The beginning, actually, Jen has some idea of best student competition. The other is gradually, like every year, some new idea. And the high profile panel discussion actually is the key from the beginning, because that time I want to attract people, we want to put people that people want to come and listen to. And this is the panel. It seems that it's organized by me, but I'm not quite remember. You can see the Montgomery and Wiggle and the other. At that time, the JQT declamations are QREI, and then the IEEE on reliability, and then several others. Any journal we can think of, we invite the journal editor. And it's surprising, they all say yes. And so that's the beginning, and later we still follow this tradition. We try to have the high profile the panel discussion. Later we add into those the founding sponsor panel. And then the other one, 205, and that actually is around the time I've been the chair. I've been the chair elect in 203, and then 204 is chair. 205, this one I remember that time is in California, San Francisco. So it's again this the high-profile panel discussion. And more recent one, 2011. Let me hear. So actually, it's in line with being assistant professor or associate professor, and then in different stage, actually I gain different things, and then usually not recognized at the very beginning. And as I look back, actually there's many things that help a lot. And then later year, I've become a department head, but I still keep participating. You can see some senior face actually. Over a year, some people are always here. I really appreciate that. And I'll talk more about this later. Okay. So, yeah.
That picture is all formal chairs in that year.
This one?
All formal chairs by that year.
Right, 2011, all formal chairs. I actually have several pictures, and this picture below, I see that I have more people, but they're actually all formal shared there. An assessment of how the field has evolved and what are the emerging research challenge and opportunity of QSR, and how the field has evolved. I know the timing. So basically, I put in here, the first page I put in, because when we talk about the involvement in this area, it's somewhat in line with the JQT. It's like it's probably a biased editor here. But happened this year is also the JQT's 50-year anniversary, so we actually put together a special issue, special paper. And this is the special discussion paper, 50 years of JQT. And then beginning to talk about history and then see how the thing evolved. Jeff was right. Actually, there are some, especially for industrial statistics, there are many important things actually happen in technometry as well in JQT. So actually here lists about the history and then look forward what will happen. And there's a discussion paper, and we invite several people together. There's quite a lot of page there. I will not talk about detail, and I encourage you to read that. And then right now, for this year's issue, that's the most downloaded paper, so it's fun to take a look. And there's some chart and the other. And we'll talk more later of the JQT invited session, so actually we'll talk more about that as well. And then in terms of move forward, we have several special issues this year. There are 3 special issues. The thing I put in here, I will show you quickly, not getting detail, is that even though the JQT played quite important role for industrial statistics, quality, reliability over the year, but move forward, already several speakers talk about the machine learning, big data, and the other. The things actually are changing. And we know that there is a new problem and evolving the new tools. And we'll play an important role, we all know that. But when we come on a new problem, we write out some new research, they may not submit to JQT or our own quality journal. So they may go a different place. So for example, we do research on big data. I think people probably will not think about the quality related journals. So how that, I mean, people submit to that journal only look at what paper has been published in that journal. And if you do it that way, the thing will never change. So I think that's the reason that actually put together that 3 special issue. There's also a gesture, even though it's not mature, put a gesture that we are interested in this area, and I encourage people to submit. But exactly what's the unique problem, be frankly, even though we already have the 3 special issue, that unique problem, the niche, is still not that clear. But I think that's all of us need to do that. And so the 3 special issues put together, one is the reliability maintenance with big data. So that is not the reliability. Some people think it's a mature area, but many people doing that. But facing the big data, the real-time sensoring, and how that problem get involved, and then it'll be interesting to see that. So that's just one of the things. Okay, people to take a look at. They may not have a solution in that issue, but that's actually on to get your interest. This is the invited paper. The second issue coming out in July is a quality engineering for advanced manufacturing, and we believe that people talk about advanced manufacturing, so the way we do manufacturing, just an example, actually is a bit different. And then apparently that will be a new quality of reliability problem, and then on-time, real-time sensor, and the industrial big data definitely is the thing. And then, so what's the unique thing, and then what kind of new research you need to look into, and so that basically, that's the issue we put together. The guest editor actually also put together an overview paper, put together their view in this area. They're also quite interesting, so I'd like the people to take a look. And the third special issue, supposed to coming out in October. It probably will come out like within either today or tomorrow. That's what they promised. The thing is that this year, there's really many things happen for JQT. So also they become online, so which is a good thing, but also cause some delay. But this issue will coming out about the statistic process control of big data stream. Because of big data stream, the previous monitoring problem or related diagnosis and the other, I think there's something. And it's actually quite related to the gens, the keynote, and there's many problems that we are interested. So that is a special issue, and I want to get people's attention. So I think that kind of summarizes that when I talk about how the thing going to evolve, and that actually is also in line with my view. And then the second thing is my vision, how QSR lead to the next generation academic needs. I usually don't talk about the vision, it's difficult to have a vision, but that's a thing they proposed. Generally speaking, I put together, just put the bullet point, the research in education, in terms of how to lead for the next generation. The research, of course, the people are interested that we doing research, we publish in the area. So I mentioned that the publish in the emerging field of analytics, including data analytics, industrial big data, machine learning, we publish that. And when I say publish, it's not just encourage the young people to write paper, to publish also. I'm talking about the publisher, I mean the journal editor is somewhat need to accept that paper. So but exactly, so now also talk about the new journal, I mean within Informs, but exactly what's the unique problem in our field, and I think we need to define that more clearly. And then because we know it's important, evolving, but probably the other session or the other cluster, they talk about the same thing. Everybody know that machine learning, big data, analytics are important. So it's good and bad. So if everybody talk about that, and then what would be our uniqueness? I think that probably need to identify and clarify in terms of research, and the education should go with that. It probably it's not just research. So at the same time, we need to revise, update our curricula in the way of teaching, refer to the active learning. And there is something, actually, it's not a topic today, but the mode of teaching actually is also evolving. So what are new toolbox to add to our field? And we usually get used to use statistics, that's important, but in addition to that, now they evolve and develop new method in the machine learning and the other area. Those new toolbox, so somehow we need to see how to incorporate. It's not just for research, also for our teaching, so that can be become a good loop. And then advice to earlier career researcher. This is a nice topic, and then if those young people they are interested, we can talk offline more. I think many advice depends. Something I immediately think of is the first is find just personal view. Different people, different advice, different view. You decide. The first I think find a mentor is one thing. Not just a mentor, it can be mentors. My point of view is that the time I graduate, and I realized that time is not the end of the education. I feel that over the year I'm still learning. Yeah. And then after graduate learning actually is quite important. And then there's many things after several years I just realized. And then different stage you need to learn different things. It's always good to have a mentor or some people willing to share with you their thoughts. And sometimes it's very helpful. And how to get the mentor, in addition, not necessarily to be an academic advisor. The academic advisor, of course, is helpful, but after you graduate, they can be someone else. Possibly someone in your department, but sometimes it's not. And the one thing helpful actually is that platform I mentioned. Platform actually is that QSR definitely is a good platform. People sit together, you can see those pictures I just showed you, like in 98 or later. You can see actually people, young people, senior people actually been together. And it's from the very beginning, I feel like I met Susan and the other people. And the attitude those people actually treat, I mean, they no matter, the thing is a very nice environment and the platform, probably because of tradition, in the sense that they don't really treat you differently, whether you are a student or junior and senior. So I see that over a year, the attitude is pretty much the same from the beginning, and that actually is quite warm. And I think you really need to take the advantage of this. This is a platform. One is that you can seek the mentor here, and then at least once a year you have a chance to talk to people. And then over a year, when I look back, actually that's quite useful, helpful. And then also collaborator. Likewise, you can find people about the same age that you can possibly work together. And I think that's different things all happen within this platform. I'm just lucky to have this kind of platform, and then there's many things that happen about the same time. If you purposely want to seek a mentor or purposely want to seek collaborator, be frankly, it's not so easy. And I really want to emphasize one thing is that saying it's a marathon, and then you can enjoy the scenery along the way. But I feel that for some of you, and then especially junior, it seems quite hectic, and then it's kind of painful and very tense to doing this. That's naturally because you have a lot of pressure. You need to go through some threshold. Okay, but the key thing is just, of course, very beginning is fine, but you don't always have that kind of survival mode. Just that you want to be survive. Beginning is fine, but sometimes people just get used to that. And then even after tenure, if you always have that kind of survival mode, probably you will not enjoy and doing things that you really like to do. So just tell you that it's really it's not a short run, it's really a long run. So you don't feel that you really sacrifice your time to really seek, but every stage you have a different kind of goal. So I hope that you can kind of, I'm not talking about passion, but it's hopefully you can enjoy, you look around, if there's something interesting, and then because of curiosity and the other. And then don't think that, okay, I will enjoy my life after 6 years. But don't think like that. Many people think that way. I don't think that's really, because after 6 years, you're not even more tense task you need to deal with. So that's the thing I think is quite important. Okay, so I basically just stop here. Thank you.
At this stage, I would like to welcome Dr. Barton, professor at Penn State University, and I have the privilege of taking a class from him the first semester I joined Penn State. And Dr. Barton has been a leader not just of our section, but also he served as the program director at NSF, overseeing some of the things that we do. Dr. Barton would be here to share his perspective.
Thanks, Satish. It's always scary when you have former students to call you on all the things you said to do and you don't do yourself. So before I talk about my background, I want to talk about my current position. So currently, I'm wrapping up a term as Vice President for Sections and Societies for Informs. I think many of you know that. And it's been a great opportunity for me to share news that I get from our community with the broader leadership of Informs. For example, the webinars that we just had, people at Informs leadership are thrilled about that, and they see that we're a very active section doing very interesting things. So the first thing I would say is everybody here, including me, we're fortunate, as Fugee said, to have this group. It's a group of friendly people, a group of people where senior people are happy to help junior people. So you're in the right place. This is a good place to be. So again, I'm going to try and follow Satish's directions. So I will say, boy, you make me feel so old, Susan. So Susan's saying, oh, her first Informs was 1990. So I presented failure rate regression models applied to criminology at Informs in Atlanta in 1977. So, but after that, honestly, I had no interest in being an academic. I went into industry, was there for about 10 years. The first part was in consulting. That was a lot of fun. At that time, I was an optimization guy. And so we were doing optimization on a variety of things. Big data in those days meant 275,000 injury reports. And the story was the same as it is today, really. The Department of Labor contacted us and said, Congress is yelling at us because we make every company collect all this workers' compensation data. What can we do with it? Tell us. So they gave us the data and we had to tell them what was interesting in the data. The RCA laboratory story, I was there about 8 years, and this ties in. I was also happy to hear Susan mention this issue about passion. That, to me, is, I don't agree at all. And so I'll give you a perfect example. I don't think your life is about passion, but I do think your life ought to be about happiness. So when I was at RCA, I was an optimization guy when I started there. Guess what? There's hardly any internal consulting that required optimization. It was almost all SPC, process setup, design of experiments. I hated statistics. I did this failure rate regression thesis, and I didn't want to see it anymore in my whole life. The more I did in industry, the more I liked it. And eventually I came to love it. It was not a passion, but it was a curiosity and an interest in being involved in that area. So after about 8 years there, I really did realize that I enjoyed the most teaching and research. And there was recognition for my performance at RCA that was entirely based on projects, not based on any research I did or any teaching that I did. So that's when I decided to become an academic. But I was so long after my PhD, 10 years after my PhD, nobody would hire me. So I asked, after I had interviewed a couple places, or tried to interview, and they said, we don't even want to see you. You hung the search committee. I contacted my former department at Cornell, and I said, hey, you have an opening. Here's what happened at these other places. Christina, one of them was University of Washington. And I said, you have an open position. Should I apply for it? And they said, please don't. But they said, maybe you should come as a visitor. And so that's what happened. I was there for basically 2 years, becoming a different kind of professional. And then the third year I interviewed. And I had interviews both in industry and in academia because I still wasn't positive. And so I had an offer from Bell Labs, from Philips Labs, from Penn State. I was sure I wanted to go to Penn State. So I told the Bell Labs folks that. And the group I was interviewing with was with Quark Suite. So he interviewed me when I was in that group. And so then I contacted them. I think Jeff Hooper was in charge of that whole organization. I contacted them and said, I'm taking a job at Penn State. And I talked to Quark. Quark says, oh, I'm going to Georgia Tech anyway. So he wouldn't have been there if I was staying there. So, but the fun thing was that summer, I had a chance to go to Bell Labs for about 3 weeks. So this is a long time ago, right? This is 1990. And Quark and I were working on more efficient coding for Gaussian process regression models. And we had a lot of fun. It was a short period of time, but had a lot of fun. And Quark is the one who introduced me to QSR. And I'm very thankful. I had finally, from 1977 to 1987, I was what they called isolated practitioner in Inform. So I would come to the meetings for the talk. I'd go to my session. There'd be 4 talks in the session, but only 3 people in the room because somebody didn't even show up. And so finally in 1987, I started going to the simulation community, which is my other home community. Also like this one, very friendly. Some of us are members of both. It's very friendly, very great platform also. And but got involved with QSR through the introduction from Quark, and I've been happy about that ever since. So let's see, what do I want to say now? Oh, I have to say one more thing about the time when I was RCA. Part of the work I was doing was on departure warning with CCD cameras. So in 1986, I got a patent. This is why I don't think patents are good. Take a look at the citations for the patent, 1986. So when does it run out? 2006. Nobody cites the patent for new patents because they'd have to pay a royalty. So maybe it held things up, right? And now all those other citations are from outfits like Daimler, Google, places like that. So it was a technique for tracking where a car was in the lane. Okay, I talked about all this, I think. I'd say a little bit about the evolution of QSR. I think Jan gave a great summary 10 years ago. And I basically said the same kind of features then. I'd say when I look at the evolution of QSR for the second 10 years, all the previous areas are still active, except maybe for, like Jeff Wu said, maybe robust design might be gone. At least way down from where it was before. And we have many more topics. A lot of them are shared with other communities, with data mining, for example. And a lot of interesting work that's related to big data, but for example, is condition-based maintenance is terrific. There's a lot of data uncertainty work now. And what I would say is the previous applications are augmented, particularly by additive manufacturing and more work on energy. And here I would say, for our future, I don't know if it's important for your professional success, but it's important for the human race's success for you to look at applications that are related to sustainability and climate change. So if you have an opportunity to work on wind turbines, that's great. Solar cell reliability, that's great, because I think we're all going to need that. This was just from our newsletters, right? So even our newsletters talk about titles from the Informs conference, and these are fairly recent ones. Let's see what our focus is. And again, I have to thank Jan for his leadership and for his vision. I really thought the latest newsletter with the interview was very helpful to me to look at future directions. So I want to add a few to the application areas that Jan Shi mentioned that are listed there. So I would say, think about data analysis and supportive marketing. So we have this big data situation. Jeff Wu talked about this funnel issue. There's lots of marketing questions and marketing models where I think we have something to contribute. So do we market needs assessment from online data, for example? And then we have a lot of tools that can be applied for finance and supply chain. So blockchain systems are going to require all kinds of statistical modeling, things we can do with that, I think. And a piece of work that I did that got published in 2012 that I still think has a lot of way to go. It relates to when Jan talked about this overall product design cycle. There's a piece on supply chain that he talked about but didn't talk about methodology. So Production and Operations Management 2012, there's a paper that talks about statistical process monitoring for the timeliness and correctness of the execution of a process. It could be a product moving through a supply chain, a mortgage moving through an application process, a workflow for a company where the transactional data now is all recorded, right? That's all part of big data. So I think that's another area where we have a lot more work to do. And it's try to make it fun. Like Fugee said, we're here to have fun. So you have to have that as part of your mission. It's how you have to figure out how to have fun. And I think you will have fun collaborating with people in other fields. So it's bright. That's what I would say. So we have a history of continuing to build on the work of previous people. And so I think that's an exciting opportunity for all of us to improve the human condition. I like the idea that Gossett, an industrial statistician, was able to take an industry sabbatical in 1902, a full year sabbatical in 1902. And the result of that was that not just the T statistic, but better Guinness beer. That's it.
Fugee talked about mentors. At this stage, I have the pleasure of welcoming my first mentor in my grad program, Professor Soundar Kumara. And as you will gather, as he presents, he not only has been a great mentor, but a great philosopher and a guide. Please join me in welcoming Professor Kumara.
First, thank you very much for inviting me here. And 3 times in my life I was nervous to make a presentation. Once was when Professor Sierra wanted me to talk in a workshop on wavelets in 1998. And before me there were 2 stalwarts. One was David Mumford, Fields Medal winner from Harvard at the time, who worked on computer vision. And the next one was Professor Donoghue, who worked on wavelets. And I was an young assistant professor who was going up, and I was shaking in my boots. The second time I was nervous was in 1992, when I was making a presentation in my platform, which was the International Academy of Production Engineering, CARP. Professor Jerry Clusty was sitting in the audience. He was very famous for stopping the speaker and telling them, "Don't waste my time." And it was, I could see that. And today I saw another stalwart standing here and talking, Professor Jeff Wu, and I'm nervous to present my views. Not that he's scary or anything, but the intellectual powers of these people is so high, and I'm only picking pebbles on the shore of knowledge. That's what Newton said, who am I? So this is me, and then thanks to Jane, Dr. Jane Shi, and all the people who worked on the QSR group, and to all the organizers of the event, to all my students who are my best teachers. I got my PhD from Purdue with Professor Kashyap from electrical engineering, so my background is essentially signal processing and pattern recognition and artificial intelligence, and Colin Moody, who was in production. Kashyap was a direct student of Professor Larry Ho, at Harvard. So I can claim that I have the honor of being the academic grandson of Professor Larry Ho. I think most of you may possibly know him. And then I joined Penn State. I had joint appointments with computer science and IST. I have collaborated with Professor C.R. Rao, whose name most of you may be familiar because of the statistics background. And I have served as visiting faculty in all these places. I started with one of the terms which Professor Jeff Wu was mentioning. Okay, he didn't take up manufacturing, it was good. I took it up, but I branched into sensing, so it turned out to be very good for me. And then I did, these are the streams of research I tried to integrate: logistic systems modeling, and then sensor data representation and analysis, and studying large complex networks and IT in manufacturing and healthcare. Started on a grad course in 1987 on AI, which I teach even today, but with different content and different emphasis. And then a grad level course in IT, which is morphed into data analytics in 2008. So these are some of my things. Research journey, to summarize 30 years of research in less than 10 minutes is not possible. But what is the question? The first one is, I started in AI, as I told you. The first book in industrial engineering discipline was edited by me, Professor Kashyap and Al Soister, who was a pioneering or a leader in industrial engineering. I started with toolware monitoring because in order to produce a good quality product, the tool has to be in perfect condition. Professors Pandit and Wu in Michigan, they worked on it for a long time. And then that fascinated me, so I took that one up, and I did a lot of work in that area. The first question I asked was, what should be my representation? If I want to really do things in a faster manner, representation is the most critical one. So signal representation there. So I studied a whole series of things, from the time series to ARMA models to ARIMA to Fourier transforms to wavelets. And one of our first papers in wavelets was around the time of 91, 92. And then from that I went into, instead of telling the tool is good, bad or ugly, I want to calibrate it over a continuous spectrum. So then what I started doing was trying to continuously monitor the tool. Then with Sagar, was one of my earlier students, Sagar Kamarthi, in 1993, we did an in-depth work on that, and which came into ASME Manufacturing Science Journal. Then, after working on that for a while, then I asked the question, instead of simply representing the signal, why can't I characterize the signal? So, can I say this signal has certain kinds of properties? That led me to studying the nonlinear dynamics part, what people would throw away as transients. I started looking into, can I understand the transient part of the signal? That took me to the path of chaos and fractals, and we have done a body of work with Sagar Kamarthi as well as Satish Bukkapatnam. Now I'm continuing that with his student, who happens to be my grandson, who is at Penn State, but as a colleague, not as a student. So in the sensor data fusion part, I worked on condition-based monitoring. I did a lot of work for the DoD. Yeah, in that particular space, we were looking into gearbox monitoring and then trying to study the propagation of defects over a period of time. We came up with a pretty good technique using wavelets and the spectral energy in the wavelets. So looking into the scaleogram of the wavelet, we were able to come up with very good indices for predicting when the gear is going to fail. So that is the whole one body of work, and then the collaboration with Uding in this particular community, we did write a fairly good paper on the state of the art on sensor data fusion in the IEEE Automation Science and Engineering. So when I was doing this, the intriguing thing to me was on when the sensors grow large in size, instead of 7 signatures or 10 signatures or 10 sensors. How about if my sensors become millions? So that took me to another path, and which I think I can. This is. I will skip all this in the interest of time. I think you will share these slides with the audience. So here are some of the key publications we had, along with telling you that this is not vaporware. Actually, we instrumented a lathe, a set of lathes actually, and then tried to pick up signals. This is a whole body of work from 1989 to 2000. Excuse me. So this is all of you know about this. And this paper we feel is significant. We proved for the first time the existence of chaos or low-dimensional chaos in machining. So there is no way to conclusively prove it, but experimentally with empirical data we were able to do it. 1995 physics reviews paper. We thought this will give you a different kind of a representation for the signal. You have the signal features, but add on top of that the fractal features like correlation, capacity, information dimension, and also the Lyapunov coefficients onto that. Maybe you will be able to do a better prediction. We thought it will change the way quality is going to be, and it took time. Now I see a lot of interest in this particular work. And again, this is all to show the proof, and this is on the scaleogram part, how energy is distributed over a period of time over multiple scales, and you can come up with an index by using this. Perhaps I haven't published all these papers in the quality journals, but mainly in ASME and CARP transactions, and also in IEEE transactions. And collaboration, as I told you, with Professor Uding here. In the different parallel path I pursued from almost year 2000 was on graph analytics. I didn't call it analytics. I just simply called clustering large networks, Internet of Things. Everybody knows about it these days, and by 2020, 4 billion people and 31 billion devices are going to be connected. So this is going to be networks of people, networks of things, and networks of events. How are you going to deal with such information explosion? So I studied it from 2000, almost 1999 to 2004, 5, and 6, and still I'm continuing on that. We did publish a paper on a very, very simple algorithm. In the sense, we all know that our parents always tell us, don't go with this person or don't go with that person. The reason for that is if we go with people who are drinking, we may start drinking a lot. We go with people who are smoking a lot, then we start smoking. So then I said, if I'm a node and I'm connected to 10 different nodes, if 6 of them are red color and 4 of them are blue color, then I tend to take the red color. That's how I propagate this color throughout the network. In the trivial case, the whole network can be one cluster, but most of the practical networks we analyze from the YouTube to healthcare data of almost 2 million patients, we see that that is not the common thing. So this paper, which got published in Physics Reviews in 2000, this year was picked up as one of the milestone papers for that particular year. Physics Reviews was celebrating 25 years of its growth, and then we were happy that this was. And this is a part of all kinds of software. This is a proof that people have used it on 500 million nodes networks. And then this is a part of all software you use, R and Python and iGraph. If you say label propagation, that is one of the important things. What is the connection between sensors and this? Sensors grow large in size and signals grow large in size. You may not be able to have the time to process all of them. Then you may want to cluster them. That clustering can be done by some common interactivity between these signals orthogonal features. So in recent years, we did converge on that with Chen Khan. I'm not sure whether he's here, and Hu Yang, who is here. We did work on it to look into machines together in a parallel manner and trying to see are there any commonalities among them by constructing networks. Then obviously I can construct the clusters out of it, and from these clusters I can induce the cluster's dominant property onto the individual machines. So at least you have a solution to start with, and then you can do further detailed analysis. Instead of dealing with 1 billion people on Facebook, imagine you have only to deal with 100,000, which is much simpler and easier to do. And actually, this algorithm is used by Google, Facebook, and everybody. Perhaps if we have made a patent, maybe I would have been rich, but I'm rich with a lot of good students who have been teaching me a lot. This is the continuation of that which Dr. Yang said. And we are even applying the same thing to spatio-temporal dynamics, trying to study images as they change over time, and trying to look into the recurrence network. So I did a quick word search, another word that comes in Elsevier publications last 12 years. It is machine learning, deep learning, all these things are there. Quality control is small, and statistical process quality control is very, very small. These are from the Elsevier journals, okay? And not from quality journals alone. Current state, wonderful. And Professor Jenshi gave an excellent response on all these things. And very good, QSR is doing extremely well. And personally, I've been an advisor to it, but I'm one of those people who live in isolation, sit in my room and do things, and I've come to a few of the meetings, but I had great friendships with many people in here. And then I tried to do whatever I could. And some of the things I see in the publications, I don't see in too much of diversity. There is diversity, but still it is difficult to do that. To me, it looks like spatio-temporal modeling is gaining a lot of momentum these days. Applications are evolving. I don't need to repeat everything we're talking about. Futurist, in order to tell what is going to be the future, you need to be talking about the society. I am not going to talk about manufacturing, I'm not talking about the statistical parts you need to do, which has been covered by all the eminent people before me. I think futuristic society is autonomous. Products are not just measured through quality, products are measured through their service. If you're going to go buy a car, today it is not like simply how good is the car running, but what services it can offer to me. Does it have a Google Earth, and can it schedule my appointments with my doctor? That's what is going to happen. So the notion of quality may be different 10 years from now. That is going to be integral. And that's going to be very important because of resource containment, limited resources. And resource containment is a few people who own all the resources. And then scarcity. These resources are scarce. And then there's going to be a continuous monitoring. The data is going to explode. I can talk of big data and all that stuff. The humans to homes. Humans are monitored. Their vehicles are monitored. Homes are monitored. Everything you do is monitored. What is going to happen is, today people talk about digital twins in manufacturing, but we are going to have our own digital twin. If that is the case, how are we going to do research in that space? Because that relates to machine learning, if you want to call it machine learning, or data analysis, what you had been doing, or what we had been doing for decades. Combining statistics as well as combining the, if you want to say, I'm not differentiating signal processing from statistics, but all those aspects. Data is not just heterogeneous, but the speeds, when you talk of streams, that is the speeds that are related to it. And it's going to be challenging. and adding bioadditive, like other people have mentioned. Future, I would say, though computer science looks at approximate solutions, I think my personal feeling is overall this have been slow in embracing change that comes out of computing. So maybe we need to think in terms of algorithms that are not necessarily completely optimal, but near optimal. So maybe investigating anytime algorithms for what we do might be very useful. So the foundational discipline of statistics is going to stay, but the way we are going to shape up as QSR, there may be a different direction also we may have to follow. Today, if you see data science has kind of broken down the barriers between optimization, computing, AI, this is collapsing now. And then maybe something like this is going to happen. Quality control of a service or a product is going to be intertwined with quality of life. I don't know how you measure it, but human quality of life and the quality aspects we study are going to be not different. So data analytics for different domains, yes. And then obviously some serious discoveries, some new math may be needed to deal with the speed and the streams. And future, currently we go from data to decisions. However, in the multi-scale world, where connectivity will be the prevalent, connectivity will be prevalent at each stage. Can we, in real time, identify decisions to be made and invoke the necessary data? What data we would need? So, and then second one is, can we analyze the data in a given time? We only have so many seconds or milliseconds to analyze this data. Can we learn in real time about this so that next time we can be much faster? Can we explain what we learned? It is not just simply like the computer science just telling you, okay, this is my mapping of the input to the output, but can you explain why it is so? So maybe QSR will lead us into new science and a math of multi-scale real-time decision learning. I'm putting learning there because everybody is in that learning space. I think that is what, in terms of the big data, I had been involved with the Indian government in trying, when they started giving the what you call as the social security numbers, which is called as Aadhaar card, to 1.3 billion people. I was involved with them in analyzing the data so that I can prevent fraudulent use of that particular card. And I made suggestions on data structures for them. And then I have worked with the DoD on logistics, using the ideas I generated from nonlinear dynamics, chaos, and fractals of how they can position their logistics. And thank you very much for your friendship, and hope to continue another 20 years with Genshi and all the other experts in this. Thank you.
Thank you. And at this stage, I would like to invite all four panelists to be here for general discussion. And also, while we are at it, I asked Kaibu how people can remember me. Right? So basically, he said, like, stand between lunch. And so basically, that's exactly what I'll be going to do. So the lunch has been pushed to 12:30 instead of 12:10, with your permission and with my apologies. So at this stage, I would like to invite all the panelists to be here so that we can spend a little time probing a little bit more questions of them. Thank you. Let's welcome the panelists. So, the panel is open for questions actually. If you have any questions, let's pose it to the panelists. Yes, Tsung.
When you in the panelist, I was wondering if the panelists may give some insights about education, especially curriculum renovation for QSR, because I think all of the panelists provide great insights into the involvement of research in terms of, machine learning, big data, data science, which is great. But another angle of this is how can we prepare our students better to do research in this area, and more generally, how do we make sure we can educate our undergraduate students better so that they can be well prepared for the research and they will have more diverse employment opportunities in different industries. So just wondering if panelists may have something to say about that.
If you have some thoughts, go ahead.
Okay, so I like the active learning thought. I will add one element to that, and we have a new course this year that I'm teaching. One of the recommendations I have is that you collaborate with the large textbook companies. So I'll tell you what's happening. I have an honors course in introductory statistics. We're using something very similar, team-based learning. The students read an electronic text that only costs them $85 instead of $300 for the regular text. The textbook's smart enough that they take quizzes on their own. If they get a question wrong, it takes them back to the section of the text they missed and highlights it in yellow. I begin my class with a quiz that's provided by, I get to select the questions. It's very easy. It's online, and it's provided by the textbook manufacturer. When the quiz is over, I present a business case to the students, and they have a set of data which they download from our course management system, and by the end of the class, they're working in teams of 3. They have to provide a PowerPoint to me that summarizes the problem, their approach to analyzing the data, and their business recommendations. So far it's going very well. It's really a lot of fun to teach that way.
I'm not sure whether your question was regarding the content of what is to be taught, or is it the way it has to be taught?
Both.
Well, so
and also the way of the teaching approach.
the second part, I think already Susan and Russ have addressed. The first part, to change the content in any curriculum is a very difficult process. Because let's say I'm teaching an undergrad IE 330, it's called Engineering Data Analytics, which has started in 2005. You come in and tell, okay, I think we need to change it, we should do something else. I'm not going to say yes to you, right? Because there is the ownership of courses by faculty, and the faculty feel threatened if you're going to introduce new curriculum completely. So any change, we tried doing it, it took 15 years to change our undergrad curriculum. Okay, so and this is from practical experience, I'm telling that. Perhaps the way to do this is younger faculty, when they think they can, and they feel that the students have to learn certain things, then perhaps you could propose like elective courses and a minor that can be taken by a set of students. When the minor, each of those courses in the minor become popular, like now Susan said she's teaching a course of organic chemistry of IE.
No, that students were afraid of the course the way they're afraid of organic chemistry.
Oh, yeah, okay, sorry. Yeah. Let's say she's teaching a course in organic chemistry in IE. Okay. Yeah. Suppose she's going to do that. Then, over like 3 or 4 offerings from 30 to the enrollment goes to 100. That will see the light of the day. I think my suggestion to you, because I have gray hair, I can say that perhaps minors in which you think through what has to be done. It will be too premature and also audacious on our part to say you should take this course, this course, this course. I think it has to come through the younger people with the guidance of mentors, obviously. There are good mentors in every department.
Okay, it's not my own experience. The content-wise, I have a new course for the postgraduate student. It's a quality technology and data analytics. So in addition to review those quality techniques, I'm adding the statistic learning content. I use the Hasty and Deep Learning's book. But in that way, I link with those the industrial data, industrial statistics, and the other. And then it's not difficult to link with what we are doing. So basically, I'm reviewing that. That's one course for postgraduate. For undergraduate student, we have original course on quality engineering, and I did not change much about content. But the recent year, the teaching mode is changing. I go through the blended learning mode. Blended means that, I'm not sure, some of you probably know, and it's called flipped learning. Yeah, flip class. So basically, you're supposed to learn in class a lecture, I make a video, you can learn at home. And those you're supposed to be doing the exercise and the other at home, but actually we do that in class. So actually, at first I'm kind of been pushing, because I'm the head, I need to lead the university pushing that, so I revised my course. But ends up, and I just realized the advantage afterwards. And those they can learn, they can learn from video. And in class, I will not repeat the lecture, but I can do more exercise, interactive learning, and that actually is quite helpful, especially now for undergraduate. But before, I know all these exercise for statistics, or rapping, and then those DOE game, and all the other, or some exercise related to statistics, and experiment. And all this I know before, but I usually don't have time to play with that. When I finish a lecture, this end of the semester. But now I actually have free time to interact with the student, and student ends up learn more, and I can immediately know that what they know, what they don't, and then I can adjust. So more interaction, but the lecture part I can push to that to the video. Okay, so that's something worth sharing.
Yes. I have a question for the audience. Do you feel that our students get enough computer skills in managing big data as undergraduates and master's level? PhD students have to learn for themselves. But
yeah, please.
From Oliver. I think at the undergraduate level, our students don't have the necessary skills. Plus, what I sense is they don't want to learn programming. They are just looking for something to point and click. That's typically among undergraduates, of course. Now, of course, I enjoyed all of your comments on active learning. Let me state, I think Russell mentioned it. Was it Russell or Soundar probably mentioned this? We tried to introduce an elective course at the undergraduate level on Bayesian data analysis. And lo and behold, from the mathematics and statistics department, serious objection. Well, we cover this in 4 courses. So why should it be offered in this another school? Well, you've got to take 4 courses to meet the prerequisites to learn the objectives of that course, but it didn't go through. So the way around that is we now offer it as a special topics course, so special topics in such and such with applications to such, well, then they can't complain. But the other issue I found, especially in large classes at the undergraduate level, how do you motivate students? They don't want to see just statistics being taught. I think it has to be somewhat, I mean, you have to be entertaining and you have to involve them. So I think I like the concept of active learning, but I'm in a sort of a dilemma that with 120 students, maybe group work or something could work to make them more involved through exercises or examples. That's just a thought of mine. So any comments would be appreciated.
Susan, would you like to pick up?
no, we started that end.
So great points, and I should say to everybody, yes, pay attention to that special topics option. That's a great way of getting a chance to cover material when some of the things we talk about are covered across the university and other departments. I would say that getting active learning is really paying off for us. I wanted to make a comment though on the programming aspect. So the students, when they get the data set, it's not necessarily in the form that they want. So in our course, this is for freshmen and sophomores, we actually cover macro generation and VBA programming in Excel, just a tiny bit of R, but they also become effective users of the formula in Excel. So when I have a quiz, I don't let them have a calculator. I tell them I'll just do the calculation in this cell in Excel.
Can I ask a quick question before we... Excuse me.
I'd like to raise this issue which we have discussed over many years and still don't see a solution. Namely, we remain a section, we are not a society. And I think our number is not big enough. Why? We're mostly academic people. We're very few from industry. We may have a few, now our student or new graduate, but once they move on, they have to join their respective professional society. Simulation is a very good contrast, but the reason is simulation has an industry. Simulation, a lot of simulation companies. Also, there's no competition. Ours, I think our biggest one is not manufacturing. It's in data analytics. Unfortunately, this is being cut by many other groups, your computer science, which is very big. I don't have an answer, but I really want to raise this again and again. Maybe not only now, but afternoon, maybe during reception. We need to think about it. There was some talk about merging data mining. Apparently, it failed or something. I support it, and the reason is I, for one, don't worry about losing our identity. I know some people, oh, reliability must be other we lose or quality. I don't think so. The reason is, think this way. Suppose you are a minority joining an empire, but if you are a very effective minority, you will have some control of the empire. We don't think that way. But I think as long as we can move into a society, no matter what, I take a very extreme position, we succeed. But if we don't, we remain a section. Sorry, so I'm doing something a little bit more negative. But I think when we celebrate our achievement, we should also look forward and worry about our future. Thank you.
Would the panelists like to address that?
Yeah, I would.
Please go ahead.
So I'll stand up so people can hear me. So I was, you might guess, since I've been vice president for sections and societies for 2 years, intimately involved in our efforts to become a society. And the biggest thing holding us back is our numbers, as Professor Wu said. That's the biggest thing holding us back. However, I guess I'm less negative about it because this is one of the most exciting subdivisions within Informs. And as I said, I talk about that with the board, I talk about that with other people. We are doing great things. I think we could have a lot more influence if we had a lot more people. And I think this issue about industry is an important one. I would like to see a show of hands. How many people are here from Minitab, the company? One person. How many people are here? 3 people. How many people are here from SAS? How many people are employees of SAS? Okay, so this is the kind of thing in the Simulation Society where we've had more success. The other thing I should say is I don't understand it, but in the past year, our student membership of the Simulation Society has grown so that the overall society membership is now something like 800 or 900. We would have no problem if we had really much greater student participation, I think, to achieve the numbers that we're looking for. And the issue about merger, I'm probably telling tales out of school, but it's not our community, Jeff, that was objecting to it so much as it was the members of the data mining community. So many of them, I won't say the majority, but many of them felt uncomfortable about it. But I think we can do it on our own. I think we can grow our membership, and we're already a very impressive subdivision.
Let me tag that with a small additional question with your permission. So let's kind of try to have some inputs from the panelists about how we can diversify our section. So the issue of diversity came up during this panel, during our earlier talks. So what are the strategies that we could even think of so that we can diversify our section?
So, sorry to take it again. I want to, because I have an interesting thing that's happened with the Simulation Society that I think connects here also. In 2007 and in 2017, I organized something special for the simulation community's annual meeting. And what I organized was 3 sessions in each meeting, which were called cross-fertilization sessions, where we deliberately invited people from outside our normal community to come and talk about topics that would be of interest to us. So I think we could have, at the annual meeting, cross-fertilization sessions where we're inviting people we think might contribute and might allow us to grow the diversity of our community.
Yeah, I've been involved in the QSR. Actually, we already tried several things in the past and still ongoing. We trying to have a joint session with ORMS, with healthcare, and with computer science. Actually, we try that every year. We'll review this session. We're thinking about diverse and try to collaborate better with the other discipline. But by saying that, I don't think it's very successful still. We remain how exactly, because still the informed community, how we get more awareness from the others, also interact more. That's still a question. I just saw a question. Satish actually asked this. Actually, that was in my PPT, but ends up I find out I only have a question about one solution, so actually I delete that. But I still think that's important if we want to say the future 10 years, how that interact with the other and get more awareness. I think that's the key thing.
I thought about not saying anything on this, but I finally decided to say something. Because Russ mentioned about the data mining thing. Okay, I am the founding chair of data mining, so I'll say more later. But I just wanted to respond. At least I will state my position on this. Okay, that I was not involved much about when they were talking about joining it. Okay, because I kind of, for those who know me, okay, once I started something, if I see other things take good care of it, I kind of phase out. Okay, same for QSR. Okay, I'm still supporting it. I brought Russ in, I brought Fugee in, and then it's in good hands. And I started working on data mining. After a few years, I thought it was in good hands, and so that was basically my style. Okay, so I wasn't involved as much in data mining. In fact, now I'm involved more in QSR. So basically, I agree with Jeff that if we have a bigger entity, then we could do more. But I also agree with Russ that I don't see reason why, like for same thing for data mining. Okay, data mining, after data mining is formed, then they form another analytics. So they're all doing data, right? They're all doing their own thing. They could do things together. So I don't see joining together is not the only way for them to grow. I mean, I see that like even Jeff is doing all this machine learning thing. I myself doing all this machine learning thing. And James's work, actually, I learned a lot from, the two-day workshop before this. So a lot of his method could be applied to lawn manufacturing. Okay, it's nowadays so much moving from manufacturing to other applications. So I learned a lot from Jen, and I'm going to go back. I don't do much manufacturing, but a lot of my work actually, a lot of method development manufacturing could be moved over there. So I do agree that, I mean, we kind of diversify, we grow. Because look at the name, quality, reliability, and statistics. It's a very broad name. In fact, you look at reliability is already moving to PHM for those who do research, right? PHM is all data-driven stuff. And we could, data reliability, basically, data-driven reliability. So all these we could grow, we could branch out. So I really think that we have a lot of opportunity here.
So with that, Fugee, you still have a question?
I was going to make maybe a comment about Susan's question. So my name is Philip again. I know some of you. I was going to make a comment about the coding piece. So I know that in most industrial engineering programs now there's kind of a move on the optimization side to do Groby, which we introduced students to Python. I actually moved to a business school a couple of years ago, and our freshmen for the business school, they all have a JavaScript coding course. So it's a computational thinking class that they take. And we're in analytics programs, our students learn R and Python. And we have a big data class that they do Spark and Hadoop. And I actually feel that the biggest, we have two areas where we can contribute the most. One is on the data wrangling side, so kind of the data engineering, how to prepare data for analysis. And then the other thing Professor Kumara kind of talked about when he talked about, can we explain what we learned? And I feel based on our training, we have the opportunity to talk about ethics and making sure that we're not overfitting. And these are two areas that I feel that people with statistics and industrial statistics background, we can make sure that the community learns. And I just wanted to know your feedback and opinions about these.
Let me try to address this issue. I struggle with this, like whether our IE students should learn programming. So 1989, I tried introducing an undergraduate course in algorithms, essentially trying to teach them how to code in Pascal, some of the basic algorithms that are used by IEs. I had tremendous opposition. Finally, that course became a course, one-credit course to teach Word, PowerPoint, etc. And then I told them I will never teach this. And the last time I taught was the head of the department, Ravi, called me and told, can you teach this the last time? After that, you don't need, this will not be offered. So it's a very difficult proposition. Having said that, the world is moving towards data. And then it's already moved towards data. And there are a lot of online resources available now. Even in every university, if I want to learn Python, there are Python clubs. So in our departments, the Informed Society, they organize Python classes, they organize MATLAB classes, they organize R classes. So that is one way to expose. That predominantly it is used by the grad students. The only way you can impress upon undergrads is you give them a project in your undergrad course, which they have to use this language. I do that in my undergrad 330 course, whether they have to use R or Excel or Python. I haven't started on Python, but R and Excel is. I think the only way is slowly doing it more than a course, because if you say I want to teach a programming course, computer science will come and tell you, oh, we are already offering a service course. There will be opposition from the college. You need to do that in a manner that teaching statistical methods, but put R as a vehicle through which you teach it.
So with that, let's all join me thanking the panelists. I hope you all enjoyed as much as I did learning from the panelists, and thank you for a wonderful session as well as the workshop through the day, and look forward to a wonderful lunch and afternoon sessions. Thank you again.